We have two more advanced set operations to talk about before we move on to something different, the first of which being an incredibly important operation, which is called the power set. So the power set is defined as follows. Given set A, the power set of A is the set of all subsets of A. The power set of A is this collection of other sets. So we're creating a set of sets here, which is something that we are in fact allowed to do. Remember that. And it's the set of all subsets of a particular set. So the denotation is P, which is like cursive P. P of A is equal to the set of all sets B, such that B is a subset or equal to A. So notice here specifically that we are doing subset or equal to. Now remember that every set is a subset of itself. So because of that, we will immediately get for all sets, the set A is always an element of the power set of A. And not just that, but the empty set is a subset of all sets. So the empty set is always an element of the power set of A as well. So because of this, we already know that every power set is going to contain at least two items, except for one particular power set, but there will always be the set itself and the empty set. For example, we will say that the power set of the set 1, 2, 3 is equal to all the subsets of 1, 2, 3, which is first the empty set and the set itself, which we know, but we also have all the one item sets. So the sets 1, 2, and 3, and we have all the two item sets as well. So the set 1, 2, the set 2, 3, that was a terrible squiggly line, and then the set 1, 3. And all of these sets together make up the power set of the set 1, 2, 3. Now we'll talk about later that it turns out that the power set grows in size very, very, very quickly. So quickly that it's actually used in a lot of important theorems. However, we won't talk about that right now. The final power set example I'll give, which is kind of fun, is what is the power set of the empty set? Well, consider all the sets that are a subset of the empty set. Well, there's nothing inside of the empty set, so the only set that's a subset of the empty set is the empty set itself. Now notice that this is not the empty set. This is different. This is the set that contains the empty set. So if we were to write this out using squiggly brackets, it would look something along these lines. So yes, very important distinction. The empty set is different than the set that contains the empty set. But this is the only power set that contains only one item. And as an example that I'll leave for you, and I'll call this a level 70 example because it is a little challenging to think about, consider what the power set of the natural numbers is going to look like. This is going to be infinite, but what items will be inside of this? Start to list them out and think about it. Now, before we talk about our final advanced set operation and our final set operation in general, we need to discuss something called tuples. Now, a kind of a bummer about sets is that they only allow for unique items and they have no order. However, sometimes we want to contain duplicates and we want to know how many duplicates we have, and we in fact care about the order of items. So we can't specifically do that with sets. So we need a new type of object, and this object is called a tuple. It is a list of items T1, T2, Tn, where all of these items have an explicit order. You can order them out, and these values are allowed to be equal to each other. So we can have duplicates and we have an explicit ordering. There are often special names for tuples, which I think they're particularly funny, so even though it's not really important to remember them, I like it. So if there's a tuple that only contains one item, it's often called a singleton. A tuple that contains two items is called an ordered pair, so remember that from your grade school algebra class. And then after that, the creativity runs dry. Any tuple that has k items where k is bigger than 2 is called a k-tuple. Why? Well, why are we talking about this? Because the final operation that we have to deal with involves tuples. So specifically, this is called the Cartesian product. So the Cartesian product of the sets A and B, so in this case, we'll just do two sets. It's the set of all ordered pairs where the first item is inside of A and the second item is inside of B. So writing this out in set builder notation, A Cartesian product of B is equal to the set of all ordered pairs A comma B, such that A is inside of A and B is inside of B. Now notice, this is very, very important, that because the first item is inside of A and the second item is inside of B, This means that it is entirely possible and very often the case that A cross B is going to be different than B cross A, or A Cartesian B, B Cartesian A. For example, the set 1, 2 crossed with the set xy is going to be equal to the set 1x, 2y, 1y, and 2x. But see that if we instead made it so that we were crossing with xy cross 1, 2, we would actually reverse the order of these elements. So just because you are using the same two sets in your Cartesian product operation does not mean that the Cartesian product goes both ways. The order actually matters. Not only this, but if we had multiple sets, so for example, A1 cross A2 cross A3 cross ... cross AN, for example, this would not be successive Cartesian products. In fact, this would be the set of all n tuples, where A1, A2, AN, like this, such that A1 is in A1, A2 is in A2, and AN is in AN. So this operation is not only not commutative, so you can't switch the ordering, but it's also not associative. So if I was to do, for example, A cross parentheses B cross C, that would be distinctly different than A cross B cross C, because what we would get here is we would get an ordered pair where this would be item A, and then this would be an ordered pair with BC, like this, and then inside of this set we would have triples, A, B, and C. And as a final example that I will leave you, and this one's actually not too challenging, I'll say this is a level 25 example. Consider the set A equal to 1, 2, and then write out what is A crossed with the power set of A. So what would this be equal to? I'll leave this as an exercise for you to do. If you could do this out, then I think you're totally good to go. If not, leave a question in the comments and I'll be sure to answer it.